Okay, so in this 2D motion review problem, we're looking at an airplane traveling at 160 kilometers per hour and wants to drop supplies to flood victims isolated in a patch of land 160 meters below the aircraft. And they're asked how many seconds before the plane starts overhead should these supplies be dropped. So this it's an interesting question in that the 160 kilometers per hour is not required in this problem. Could be required if we were to ask how far from the patch of land horizontally would the plane need to be before it drops, and we can solve that problem. But in order to solve for the time, I'm going to assume that the airplane is traveling horizontally at 160 kilometers per hour. So I mentioned it's not necessary to. The speed is not necessary, but I'll do an extra problem. So this is equivalent to 44.4 meters per second. You just need to convert 160 times 1,000 to get 160 into meters, 160 kilometers into meters, and then divide by 3,600 seconds, which is the amount of seconds in an hour. But the key thing here is that the initial y velocity is 0. So if we want to find the time knowing how far the objects have to drop, we can use this equation for delta y, biy delta t minus 1/2 g delta t squared. But we just stated that the initial y velocity is 0, assuming the plane is traveling horizontally, so that whole term goes to 0. So that means that negative 2 delta y divided by g is equal to delta t squared. So delta t will be equal to the square root of 2 times delta y, negative 2 times delta y divided by g. And so if we solve this calculation, we have negative 2, the delta y again is going to be negative 160, so again we can't take the square root of a negative number. Then we'll end up with a positive time, divided by 9.8 meters per second squared. And you can work that out in your calculator. It's 5.7 seconds. So that's how much time seconds before the plane is directly overhead that the plane should drop. But if you wanted to do this in terms of how far from, what's the horizontal distance from the small patch of land, you could figure out the delta x that the plane would need to be by considering how far this object would travel at this speed. So the box will be dropped with no initial y velocity but having the same velocity as the airplane. And if it's dropped for 5.7 seconds at this speed, assuming no air resistance, we could figure out the distance by multiplying the velocity times the time in the air, and that gives you 254 meters. So again, not necessary, this is not asked for in the question, but you could state that the airplane, when it is 254 meters, which would be it would take 5.7 seconds to travel that distance, that is when this supply should be dropped, such that it lands on the patch of land.